So this is A2U2L2a Linear functions. Let's talk about some vocabulary real quick. A linear relation is a graph that's in a straight line. It's not curved or swervy or anything, it's just a straight line. So let's look at just a sample equation, x plus y. How many possible solutions are there to this equation? You could have 1 plus 7 or 0 plus 8. You can get into negative numbers, you get into fractions, and the possibilities become infinite. You could never find the end. But if we graph it on a piece of graph paper, we're just going to get a straight line, and that's going to show us every possible solution everywhere on that line. So that's why it's kind of convenient. Now we're also going to be talking about standard form. Standard form looks like ax plus by is equal to c, where c is a constant. X and y are going to be variables, and a and b are also going to be numbers, coefficients. Now they could be 1, and we know 1 is the invisible coefficient, so like these two right here, their coefficients are 1. Now there are some stipulations, and these are the rules about what is standard form, and this is what we don't pay attention to a lot of times. But if you are asked to put an answer in standard form, it has to be in this order: your x term, your y term, your constant term. Now, a, b, and c are integers. Now we've talked about our number set, so you know what an integer means. Also, a has to be greater than or equal to 1, so you don't want a negative here. It can't be negative. If it were 0, it wouldn't exist, so that's why it starts at 1. Then the last thing is you cannot have a greatest common factor of a, b, and c that is greater than 1. It has to be 1. So knowing these 3 rules is going to let you know when you have it in standard form or not. So let's just practice putting some equations in standard form real quick. Okay, for number 1, we want to put this in standard form. So the only thing actually wrong with this one is the negative in front of it. So how do you fix that? How do you get rid of a negative? Well, we're going to multiply by -1 all the way through the equation. So that's going to make that positive 5x. It's going to change that plus to a minus. Minus 6y is equal to positive 12. And that's all you have to do to that one. Okay, for number 2, we've got y is equal to 2x minus 9. So we need to do a little bit of manipulation here. I need the 2x over here. Now if I subtract it from each side, I'm going to have a negative, and then I'll have to multiply by -1, which is fine. But another technique you can use, anytime your x is positive and on the right hand side, you can't just invert that equation and put, let's just start off by flipping it. So now I have 2x minus 9 is equal to y. So now I have 2x where I want it, and it's positive. Now let's get rid of the y, so we're going to subtract y from each side. 2x minus y minus 9 is 0. And then to finish up, we'll add 9. So now I have 2x minus y is equal to 9. And let's check the 3 points. Is there a greatest common factor? No. Is this negative? No. And this is greater than or equal to 1. So we're good. Okay, let's look at number 3. 9x plus 6y minus 24 is equal to 0. Well, first let's get that 24 over there. Since it's been subtracted, I'm going to add it to each side. Now I have 9x plus 6y is equal to 24. So let's check. Do we have a positive number in front? Yes, we do. Do we have all integers? Yes, we do. Do we have a greatest common factor? Also yes, and that's something we don't want. So what number will go into all 3 of these things? 3. When you divide 3 out of that, you're going to get 3x plus 2y is equal to 8. And that is standard form. Okay, let's look at number 4. 7y is equal to 7 minus 7x. So I need the 7x over here. Now in the other one I inverted when it was over here, but this time it's negative. So to move it, I can add, and that actually takes care of 2 problems at once. So that's why I'm not inverting this time. So now I have 7x plus 7y is equal to 7. So let's check our 3 things. Do you have no negative in front of your first term? Correct. You have all integers. We're good there. But we do have a greatest common factor again. All of these can divide by 7. So when I divide each term by 7, I'm going to get x plus y equals 1. And there's your standard form. Okay, let's look at number 5. Now, as far as why is it not in standard form already? Well, it's because the coefficients of x and y are not integers. So we're going to have to change those from fractions. Now, you can do that by multiplying by the denominator. And I could multiply all the way through by 4 and then come back and do all the way through by 3. Or I can think smart and just do it by 12, because 3 times 4 is 12. So I'm going to multiply every single term by 12. Now 4 will go into 12 3 times, and 3 times 3 is 9x. 3 goes into 12 4 times. 4 times 1 is 4y. And then 12 times 1 is 12. And that is standard form. Check it. There is no negative, everything's an integer, and there is no greatest common factor. All 3 things. Okay, let's try number 6. Now we do not have an integer, first thing. We have a fraction that we'll need to get rid of, and then y is going to need to come over here. So let's get rid of the 1/6 first. We're going to multiply all the way through by 6. So that's going to give us x equals 6y minus 12. Now to move the 6y, we'll just subtract it from each side, and that's going to give us x minus 6y is equal to negative 12. So let's check it. We do not have a negative in front of the first term. That's good. We have all integers. That's good. And we do not have a greatest common factor. So we're good to go. Now let's talk about the slope-intercept form of an equation. This should be a review, but please pay careful attention and make sure there's not something that you've misunderstood from the past or that you've forgotten. So slope-intercept form looks like this. Y is equal to mx plus b, or it could be written f of x is equal to mx plus b. Remember, anytime you see f of x, that's interchangeable with the letter y. All right, m is your slope. And a slope is rise over run. The top number tells you how far up or down you go, up for positive, down for negative. Run tells you how far to the left or right. When you put those two together, that's when you get a slant. All right, B is your y-intercept. That's the point where it crosses the y-axis. Now I want you to think about the ordered pair that describes that point. What would the ordered pair for anything on the y-axis be? Well, your x-coordinate is going to be 0 because you're not going to the left or right. So your y-intercept is always going to be where x is equal to 0 and y is the point of intersection. Slope can also be referred to as the rate of change because it's how fast whatever you're graphing is changing. And there are 4 types of slope or 4 types of change. The first one is if you have a positive slope and your line's going to look something like that. Then if you have a negative slope, well, it's going to go in a downward direction like that. Okay, what about the other two now? You might have a 0 slope, and that is a line that is going to be horizontal. It's just going to go straight across. I always say think of it as a difficulty rating, and if you're trying to walk across a straight flat line, that has 0 difficulty. Now, there's one more, and that is our undefined, and that's a line that goes straight up and down. Okay, undefined goes straight up and down, and that's when your denominator is 0. And I also say, think of that as a difficulty rating. It's not that it's hard to walk up a straight line, you just can't do it. It's undefined. Okay, so let's look at some problems now. So for number 7, we're going to take y is equal to 2/5 x plus 7, and they want us to put it in slope-intercept form and then graph the line. Now it's actually already in slope-intercept form. So the coefficient of x here is my slope, and my y-intercept is at 7. Now remember, a y-intercept always occurs where x is equal to 0. So let's graph the y-intercept first. I'm going to go 0 to the right or left and up 7. 1, 2, 3, 4, 5, 6, 7. So that's right there. Now, My slope is 2/5. So my first number is my rise, my bottom number is my run, rise over run. So I would rise 2 and run 5. 1, 2, 1, 2, 3, 4, 5. Now, if it so happens that you don't have enough room on your graph to go up and over, look what else you can do. This slope is positive, but you know what? Positive 2/5 is the same thing as -2 over -5. So this is an interesting concept. So I could go backwards. If it's positive, you make both of them negative, and you could go down 2 and back 5, and you see how you wind up on the same line? It's just the other side of it. And this is one thing that I get asked a lot about where to put the negative. I want you to pay attention to this. If I have, say, -3 over 7, that is the same thing as 3 over -7, and that is the same thing as -3 over 7. All of these things are negative. One negative. The only thing you cannot do is turn around and say, well, that must be -3 over -7, because this is positive. So when you have a fraction that has no negatives in it, then yes, you could use both negatives. But if you have a fraction with one negative in it, you make sure that you have one no matter where it goes. Number 8 says f of x is equal to -x plus 2. Now remember, f of x is the same as saying y equals. So, all right, what is our slope here? Well, it's the coefficient of x. And since you don't see a number there, it's understood to be 1. So our slope is -1. Now, it's easier to do slope if you put it in fraction form. That's what I was talking about just a minute ago. You can put -1 over 1. You can put 1 over -1. As long as you only have one negative, your slope is still negative. And then our y-intercept is going to be at 0, 2. So let's put that y-intercept down. We're going to go 0 to the right or left and up 2. Now for our slope, we're going to go back 1, up 1. And you can put another point if you want to. Back 1, up 1, all the way down. So there's our line. And you see it's a negative slope, so it's headed in the downward direction. That means whatever you're graphing is decreasing. Okay, for number 9, it's going to require a little bit more manipulation to get it into y is equal to mx plus b format. But basically, we're just solving for y. So first, let's subtract x from each side. And to keep that in slope-intercept format, I'm going to put the minus x in front. Now I've got to divide all the way through by 3. So these cancel out or divide out to 1. Now, right here, I've got -x over 3. That's kind of hard to read the slope from. So what we want to do, how do we rewrite -x over 3 as something with just a fractional coefficient? Well, we're going to make that -1/3 times x. -1/3 times something is the same thing as dividing by 3. And then 15 divided by 3 is 5. So here our slope is -1/3, and our y-intercept is at 0, -5. So let's put a point at 0, -5, 0 to the right or left, 1, 2, 3, 4, 5, right here. Okay, now for this slope, -1, 3, we're going to rise -1 and run 3. So rising -1 means go down. To run 3, I'm going to go this direction. So there's my line. Okay, number 10, 4x plus y minus 1 is equal to 0. Let's get it in slope-intercept form first. So we're going to get rid of the 4x and the minus 1. So let's just do minus 4x and plus 1 on both sides. So what that's going to give us is y equals -4x plus 1. All right, our slope is at -4, which we can put in rise-run formation by putting that over 1. And then our y-intercept is at 0, +1. So let's put a point at 0, 1, 0 to the right or left, up 1. Now for this slope, remember, you're at rise over run. So we're going to rise -4. That means go down 1, 2, 3, 4, and then to run 1 in the positive direction. And you can keep going if you need more guidance on drawing your line. Okay, let's look at a couple of special lines, a vertical line and a horizontal line, and let's see what kind of an equation we can have to describe those. If we look first at the vertical line that's going straight up and down, remember that slope is undefined. That slope is over 0. But when we think about the ordered pairs that go with this line, we know that ordered pairs are always x and y, x and y. So let's just look at a couple. What about this point right here? What point would describe that? Well, I went back 3 and up 2. What about this point right here? Well, I went back 3 and up -3 and up 0. Every single point is going to have a -3 in the x coordinate place. So let's just describe this as x is equal to -3 because y can be anything, any number. All right, now let's look at the horizontal line, thinking kind of the same way. What are a couple of points on this line? Let's just find 2. This first point, I went 0 to the right or left and up 1. The next one, I went over 3 and up 1. Now do you see the common thing there? The y coordinate is always 1. So this line could be described as y equals 1. So your vertical lines are always going to be x equals whatever number on the x-axis that intersects. And your horizontal line is always going to be y equals whatever number it intersects on the y-axis. Now let's talk about the difference between parallel versus perpendicular slopes. Lines that are parallel have the same slope, whereas lines that are perpendicular have slopes that are negative reciprocals. Now, what's a negative reciprocal? Well, you know what negative means. It's the opposite of, and reciprocal means you flip it upside down. So, for example, if your given line has a slope of 2/3, then the perpendicular line has a slope of -3/2. If your given line has a slope of -7/5, then your new line has a slope of +5/7. So if they tell you that a line is parallel, then you can find the slope of that line and your new line will have the same exact slope. If they tell you that your new line is perpendicular, find the slope, make it the opposite sign of what it already is, and flip it upside down. If it's a whole number, like -5, then your new line is going to be +1/5. That's a negative reciprocal of -5. Okay, for number 13, we have 2 equations, and we want to tell if they are parallel, perpendicular, or neither. So first we're going to put them both into slope-intercept form. We'll extract the slope and then we'll compare the 2 slopes. So for this one, to get it in slope-intercept form, I'm going to subtract 10x from both sides. So now I have 5y is equal to -10x plus 5. Divide all the way through by 5. So now I have y is equal to -2x plus 1. So my slope is -2. All right, over here, to get this one in slope-intercept form first, and there's a lot of ways to manipulate these equations. You do you on that. I'm going to invert, make it 2y plus 16 is equal to -x, and then I will subtract 16 from each side. So now I have 2y is equal to -x minus 16. Divide all the way through by 2. So I'm going to have y is equal to, now remember when you've got -x over a number, to get the slope, it's going to be a fraction form. So this is -1/2 x minus 16 divided by 2 is 8. All right. So my slope here is -1/2. Now be careful. They are reciprocals, but they both have the same sign. So this is going to be a neither It is not parallel, nor is it perpendicular. Okay, on number 14, let's look at these two. First, we're going to put both of these into slope-intercept form, which is y is equal to mx plus b. So let's subtract 8x from each side. And I have negative 6y is equal to negative 8x plus 42. Divide all the way through by negative 6. So now I have y equals, all right, negative over negative is positive, and I'm going to go ahead and reduce 8/6. You can divide both of those by 2 and get 4/3 x plus 42 divided by negative 6. Well, that's going to be minus 7. All right, up here, so our slope here is 4/3. Now let's see what we have here. We already have the y here. We need to get rid of that negative 3 that's in front of it. So let's divide all the way through by negative 3. So I have y equals, all right, 9 divided by negative 3 is negative 3. Minus and a negative cancel each other out. So I would have plus 4/3 x. And to get it in slope-intercept form truly, I'm going to need to reverse those two numbers. Now, your slope here is also 4/3. Since the slopes are the same, these two lines are parallel. Okay, let's look at number 15. We have two equations, so let's get them both into slope-intercept form first of all. Over here, I'm going to add 8x to each side. So I have 8y is equal to 8x. We don't have to put plus 0. Then we're going to divide all the way through by 8. So now I have y is equal to x. And I know that looks funny, but it's in slope-intercept form. Even if you put the plus 0 there, because that's where your y-intercept is going to be, at 0, that's a point. What's the coefficient of x? 1. So the slope of this line is 1. All right, let's work on this one. We've got to subtract x from each side. So now I have negative y is equal to negative x plus 4. Now I don't want negative y, so I'm going to multiply all the way through by negative 1. That's going to give me y is equal to x minus 4. All right, what is the coefficient of this? Also positive 1. Therefore, these two lines are parallel. Okay, number 16, we're going to have to think a little bit. I've got x is equal to 2 and y is equal to 2. That's not really slope-intercept form, but we did talk about these two lines. A line where it's just x is equal to something, well, that's your vertical line, right? And it has a slope that's undefined. Now, a y equals something line goes straight across at that number, and that's a slope of 0. Those are reciprocals of each other, and 0 doesn't have a positive negative. So these are always going to be perpendicular. Okay, and that's it for 2A, so we'll move into 2B. Good job, y'all.